Okay, so this is the, I don't even know what this is. Writing equations off of real life data, okay? So, we're making out a chart. These are the high temperatures, and, this is actually comes from section 4.5, which is what we've been doing with graphing and writing equations. These are the high temperatures in these cities every month, and T equals 1 corresponds to January. All right, so number 3, that will be March. Nantucket's 42 and Athens is 65. Number 4 is 53 and 73. Number 5 is 62 and 81. Number 6 is 71 and 87. Number 7 is 78 and 90. Number 8 is 76 and 88. Number 9 is 70 and 83. Number 10 is 59 and 74. Number 11 is 48 and 64. And number 12 is 40 and 55. Okay, so for right now, just forget about these guys right here, because that's the one you're gonna do. And I'm gonna leave the answer back here. Obviously, for the video purposes, I will set it up here for just a second and let the kids that are watching on the video see it. And then they can pause it, whatever they want to, and then I'll take it away and I'll let you come back here and check yours, okay? Yeah. So the first thing we're gonna have a 50-point test Wednesday, Thursday of next week. Y'all listen to me. You need to be here to take your test, okay? Unless you're quarantining or sick, you need to be here to take your test. I mean, I know things happen and everything, but next Friday is the end of the 6 weeks. So I need all my grades to be done, okay? So the first thing I'm going to ask you to do is draw a scatter plot. So we're going to draw a scatter plot. Now I'm going to tell you this, when you draw your scatter plot, mine's easy because I'm on a piece of graph paper. But the neater and more precise you are, the better your curve will look, okay? The neater and more precise you are, the better your curve will look. So, it's a real life problem. It takes place in quadrant 1, okay? What do I need to do next? Label your axes. If you don't label your axes, you will miss points, okay? I will take points away from you. So what is the x-axis?
T.
Yes, it is T, and it's
months.
what? Months. Okay, and specifically T what?
1.
T equals 1 corresponds to January. You need to tell someone that, okay? You need to tell someone that. Everything that you know about that, you need to write right there. All right? What's the smallest T?
1.
And the biggest?
12.
And we like to hang around 10 tick marks, okay? Now, sometimes you won't be able to get 10 tick marks, guys, okay? But, if I can, then I try to. So what do you want to go by? I'm going to go by ones, okay? So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, there's my 12 months. Okay, so we're doing Nantucket. We're not doing Athens. Y'all are doing that later. So we're doing Nantucket. So on the Y's, what's the smallest Y? 40. What's the biggest Y? 78. Okay, so we're going from 40 to 78. What do you think we should go by?
5.
Fives? I like fives. And here's why. Because if you say 10, all right, then you're going to go 40, 50, 60, 70, 80. And that's only 5 tick marks. Which means if I go by 5, I should have around 10 tick marks. Do you understand? Okay. very good. So Alyssa asked about a break. So I'm gonna show you, okay? So first of all, I'm gonna call this 40, all right? And then this is 45, and then this is 50, okay? So right here, I wanna talk about what Alyssa said. So when I went from 0 to 40, what did I say I was going by? Look, when I went from 0 to 40, what does my graph say I'm going by? 40s. Do you see what I'm saying? Your first tick mark says what you're going by. I'm not going by 40s, I'm going by 5s. So what you have to do is put that little break thing in here. It looks like a little heartbeat, okay? And what it tells me is, there's a piece of this y-axis that's missing. It's broken right here, and then I'm just starting at 40. I didn't need 0 through 40. There's nothing that happens there, okay? The temperature in Nantucket never gets that low, all right? Or the high doesn't, because that's what we're talking about. All right, so, we forgot to label our y-axis. What is my y-axis? It's the average, you would know it from reading the problem, but the average daily high temp. Okay, and then what? It's in what?
Degrees.
Yeah, degrees Fahrenheit, not degrees Celsius. If that was Celsius, like would be like on fire.
Yeah.
Okay, all right, so 55, 60, what am I going to? 65,
Or no.
70, yeah, 80, 75, 80. All right, you ready? So now we're gonna graph it. So at 1, it's 40. Okay, at 2, it's 41, so that's just a little above that. I always just make really big dots. At 3, it's 42, that's a little more above. At 4, it's 53. That's a little above halfway in between 50 and 55. At 5, it's 62. At 6, it's 71. At 7, it's 78. At 8, it's 76. At 9, it's 70. At 10, it's 59. At 11, it's 48. And at 12, it's 40. Okay, so there's my curve. What's it look like?
A cosine that I flipped.
That's exactly what it looks like, okay? It looks like a cosine curve, except instead of starting at the top, he starts at the bottom, okay? Unless, Michael, you start where?
At the top.
Yeah, and then it's, I mean, because what's this thing gonna do right here? Is it gonna keep going down?
Yes.
No, it's gonna go back up.
Yeah, y'all look. This is January, this is December, okay? So he's just gonna keep on doing this, back and forth, okay? That's a cyclic function. He keeps doing the same thing, the temperature. Might there be some weird years where it maybe gets really cold or really hot or something like that? Yeah, there are, but on the average, it's just gonna keep doing this, okay? So should we be able to write an equation for this function? Yes?
Yes.
Okay, so let's do it. Do y'all want to set it up? Now y'all listen to me. Here's part of the problem right now, is that some of you don't even know where the cosine curve starts or where the sine curve starts. When I had to write on your paper, -3, wrong curve, -3, wrong curve, -3, wrong curve. I even took your horizontal shift, even if it was wrong. If you told me your horizontal shift was right pi over 2, then I went to pi over 2, And I said, okay, did they do the right curve? No, it'd be a cosine curve and you'd start in the middle. Like, no, wrong curve. It'd be a sine curve, start at the top. Like, that's sad, people. We spent more than a week on that stuff, and you don't even know what curve is what. It was the very first thing I taught you. I said, you have to know the sine curve starts in the middle and goes up. The cosine curve starts at the top and goes down. Remember? Because y'all kept saying it starts at 0, and I said, don't say that, because when I shift it and move it, that's going to mess you up. All right? So you say the sine curve starts in the middle and goes up, the cosine curve starts at the top and comes down. Okay? Some of you don't know where the middle is. Come on, people. Let's get in the game. All right. So let's do this curve right here. Do you want to do it like I asked you to do your worksheet? On your worksheet, if you did your worksheet exactly like I asked you to do it, because remember I put in a pink pen, I said make your paper look exactly like mine, because normally I give you an answer sheet and I didn't. I graded it off notebook paper, which I hate to do. So that's why I asked. If you did it exactly like mine, I said, oh, plus 10, thank you very much. I graded your paper really quick. If you didn't, then I didn't take any points away from you, but I didn't give you 10 bonus points. Okay? So here's the way we did them. Sine and cosine. Y'all remember this? All right? What did we find in the middle that's the same for both of them? What was the first thing we found? A. Okay? So we found A. What was the formula for A? Okay. Either high minus low over 2 or max minus min over 2. Either way, it doesn't matter. Okay? So what is the high?
78.
78 degrees. See, you're looking right over here, guys. Okay? What's the high? I even asked you when we made our, when we marked off our tick marks on our y-axis, what's the high and what's the low? So 78 minus, what's the low? 40 over 2. 78 minus 40 is what, 38? And 38 over 2 is what, about 19? All right, so there it is. Now, listen to me. You're not going to have a calculator on this test, okay? So you're going to have to do all this stuff. If it ends up being a nasty number, you can leave it as a fraction or you can write it as a decimal. As far as a graph is concerned, a decimal will speak to more kids than a fraction will, all right? Mainly because y'all, fractions don't like register with people all the time. All right, so next thing we have to find is B. A lot of kids still do not know how to find B. People, had you better figure out how to find B? Yes, you better figure out how to find B. Okay, so B, what's the formula?
2 pi over a period.
2 pi over the period. Now, some of you knew how to find it, but you don't know how to work with fractions. Okay? That's a 6th grade skill, people. Okay? So come on. So 2 pi over. Now, here's another problem. Some people don't know how to find the period of something. Now, this is a real life problem. So I'm going to do it mathematically, and I'm going to tell you that even if you did it mathematically, I would give it to you. Okay? I would give it to you. But then I'm going to ask you to use your brain. All right? So mathematically, do you agree that from valley to valley is one period?
Yes.
Okay? From peak to peak is one period. From middle going up to middle going up is one period. From middle going down to middle going down is one period. So valley to valley. How do I find the length from these two numbers?
Subtract.
You subtract them. Remember y'all were like going, whoa, wait, I don't know. And we talked about Brandon's height and my height. And how would you find the difference? The distance from the top of my head to the top of his head. And y'all said, you subtract your heights. I'm like, it's the same thing. Okay, so what is 12 minus 1? 11. Okay, so it looks like the period's 11. But what does your brain say the period is?
10.
Why is it 12, Michael?
Wait, did you ask?
Because that's how long a year is.
That's exactly right, because that's how long a year is. Okay, it's a cyclic function. It repeats itself. How often? Every year it starts over again. Do you get that? Okay, so if you put 11, would I count it wrong? No, I would not count it wrong. Okay, but I'm going to think about it because these are real life problems. All right, and I know that happens every year. Okay, how often do the tides occur? Every 12 hours. I'm surprised that you kids that don't know that. Y'all grew up around here, okay? I know that, and I didn't even know tides, like, I knew what they were, but I didn't really have any dealings with it. Okay, so 2 pi over 12. What do I do with that? Not know. Okay, so I now have to reduce my fraction. 2 goes into 2 one time, 2 goes into 12 6 times, so pi over 6. What is that? That's B. Yep, beautiful fraction, pi over 6. All right, the next thing I want to find is my horizontal shift. Y'all listen to me. Is the horizontal shift for the sine curve and the cosine curve the same?
No.
Did you, on the test, I had people, whatever your horizontal shift was for the sine curve, you slapped it on a cosine curve. I'm like, oh my word, where have you been? People, if one starts in the middle and one starts at the top, that is not the same place. Okay? That is not the same place. So, for the sine curve, I need to know where the middle is. Do you agree with that?
Yes.
Okay. How am I going to find that?
The middle of the period, right?
No, not, well, no, it's not the middle of the period.
Oh, never mind then.
It's the middle of the what?
Of
That first curve?
It's 40 plus 19.
It's 40 plus 19.
Oh, well, that would be the y, so never mind.
Okay, no, you're right. You're right, because that is the middle of the curve. Okay, so here's what Jacob did. Jacob, he did his, what's that called, Jacob? Your vertical shift, right?
Yes.
Which is the mean plus the amplitude.
Yes.
Or you could do what? The
Max
max minus the amplitude. That's gonna be the middle of my curve, okay? Now in just a minute, you're gonna see why I have to have that. So I'll just go down here and find it. My vertical shift is, you can either say the max minus the amp, which is, what's the max? 78 minus 19, which is 59. Or you can say the min plus the amp, and that would be 40 plus 19. And guess what, people? It's the same thing, okay? So watch what I'm gonna do, all right? I'm gonna draw it on here, and here's why. It's important where it hits this curve. So 59 is just a tad bit above, below 60. Okay, now watch what I'm gonna do, because do you agree? Look, here's my curve, see it? Sometimes it helps to draw the curve. All right, so this is my horizontal shift. Do you get it? Now, where do I get it from? Do I get it from the left, the y-axis, or down, the x-axis? Horizontal shift. Yeah, y'all, horizontal is the x-axis. This is horizontal, that's the x-axis. So pull that guy down. All right, now watch this, okay? Do you understand how important it is to be neat on your graph?
Yes.
Okay, so watch this. Do you agree it's between 4 and 5?
Yes.
Is it between 4 and 4.5 or 4.5 and 5?
4.5.
Does everybody understand that? Do you understand why? If you put 4.2, I'd be like, meh, that's close, but I'm not really liking that, and I might take a point away from you, okay? You're not totally off, all right? But you weren't as precise as you should have been. So I'm gonna say 4.75. So for my horizontal shift on my sine curve, I'm gonna go right 4.75. What about my horizontal shift on my cosine curve?
Go to the top.
Oh, okay. You could go to the top. You could go to the very top. You could say right, what? What is that top?
78.
7. All right. Or could you start it down here at 1
Yeah.
and do what?
Put your
Yeah, put a negative on your amplitude. Okay. Or you could say right 1 and make sure that you got a negative amplitude to flip that curve. Okay. Whichever way you like, whichever way your brain thinks about it.
For the vertical shift, if you've got two different numbers for the max and the min, you just average them out.
You shouldn't get two different numbers because you used these numbers to find your amplitude, so you shouldn't ever get two different numbers, okay? But that's a very good question. All right, and maybe if they weren't quite so nice problems is what they give us, then yes, you might, and that's exactly what I would have done. All right? Okay, so everybody ready to write your equations? Okay, so y is equal to, now we had a problem with the b part again in writing the equation. Some of y'all didn't do it correctly. All right, so my sine curve starts in the middle and goes up. That's perfect. I don't have to do any kind of mess to it, all right? So my amplitude is 19 times the sine of pi over 6. And then you have to have these parentheses. A lot of y'all like to put these parentheses right here, but y'all, this parentheses is mandatory. If you don't take this b off of that x, then your horizontal shift will be wrong, because you're saying that you put him back in there, and then that horizontal shift won't be this number, okay? Or this x minus won't be that number. So then x, my horizontal shift goes right, so that's minus 4.75. Close them twice if you opened them twice. These are the ones that are mandatory. You have to have those right here. Some of the kids put this pi over 6 right inside those parentheses. And I didn't mark the pi over 6 wrong, but then this is wrong. Because actually what you would get was whatever it would be when you multiply pi over 6 by this number. Okay, that's the way the book teaches it, and that's fine. But they teach you to take this number and divide by whatever the coefficient of x is. Well, that's what we do when we rewrite it, when we factor it out. All right, and then plus my vertical shift of 59. My cosine curve can be either one of these. This first one looks like this, 19 times the cosine of pi over 6 times x minus 7 plus 59.
Yep.
Or if I use my right one, I have to put a negative on the amplitude to flip the curve and make it start at the bottom instead of at the top. So that's a negative 19 times the cosine of pi over 6 times x minus 1, thank you, plus 59. All right, so anybody got a question? Nobody got a question? Okay, so here's what I want you to do. I want you to take a calculator, okay? I want you to take a calculator, and then we're gonna do the next problem. But I want you to take a calculator, and we're gonna put this on a graph, okay? So, the first thing, we're gonna do a regression on it. No, we're not gonna do a regression, sorry. We're not going to. If you do a regression, you will not win a prize, all right? So, here we go. I'm gonna put these in my x's and these in my y's. So I'm gonna go stat and edit. Mine are already in there. You probably don't. Y'all, there's calculators up there in that box by my desk. If you need a calculator, yeah, then get you a calculator. So we're fixing to make a scatter plot on our calculator. So put your x's in list 1 and your y's in list 2. These are my x's and these are my y's. And then stay with me now. Got it. edit mode right now, we're gonna go second and quit. So here's second and quit, it's just right to the right of it, all right? And now I wanna make a scatter plot, and I wanna make a scatter plot that looks exactly like this one. So I'm gonna set everything up so it should replicate this, okay? The first thing I wanna do is I wanna go second and stat plot, which is y equals. Second and stat plot. I'm gonna choose the first one, you can choose any of them, but I'm gonna choose the first one, and I'm gonna make sure he's turned on. Most of the ones on your calculator are turned on because my Algebra 2 kids are doing regressions, okay? But that's why the numbers were funky in there. All right, so I turned it on, and then I'm gonna arrow down, and then this first thing, these are all the kind of plots that your calculator will do. The first one is a scatter plot, the next one is a line graph, the next one is a bar graph, the next two are box and whiskers. The second box and whiskers is the one that y'all did, like when you were in 7th or 8th grade, because it's the one that has the median line in it. The other one doesn't have a median line. Y'all did this one right here. I'm not sure what that is. I think it's either a frequency table or a step function. I've never done either one of those on a calculator, so I never really had any use for it. So my x's, we put my x's in list 1 and my y's are in list 2. Now let me show you how to fix that if it gets messed up. Okay, so let's say we went down here and mine said list 4 right there, and I'm like, oh, no, my x's are in list 1. Above every number in blue, so that's the second, is the list. So 1 is list 1, 2 is list 2, and 3 is list 3. So I'm gonna go second and 1, and that will change it back to list 1. Then you can go down here and you can choose whatever mark you want. I, of course, am blind, so I choose the biggest mark. And then this fancy calculator will even let me pick the color, okay? So that's what I want. Now I'm going to graph it, but before I do, I'll always wanna go and change the windows, okay? Because generally what happens is that kids will go and they'll just automatically press graph. And then they'll go, oh, Miss Davis, my calculator's broken. I graphed this and it didn't show up. I'm like, well, did you change your windows? No. So always go back and change your windows. Oh, come on, calculator. All right, so my windows, my x's. What was my x min? 0, right?
Yeah.
So I'm okay with 0 because my first mark is at 1. And it goes to 12. I don't like to be on the marks, okay? So I'm gonna go to 13. If you go to the mark, then here's what happens. Your graph will look like this. You'll only have a half of a mark on the 12. You won't see the rest of it. It'll be at the edge of your window. We did go on a scale of 1. My y min was 40. But what am I gonna put in here?
35.
35, because I wanna go 1 tick mark below and 1 tick mark above, so that my dots do not end up on the edge. And then my max is gonna be 85, and we went on a scale of 5. Now it looks exactly like this, okay, with the exception of the little, where I skewed it a little bit. But when I graph it, you can see it looks just like that. All right, so if you have a curve that's already on yours, I want you to go to your curve, go to y equals, and I want you to, oh my gosh, that's what I hate about these. Go to y equals, and I want you to clear out that equation, okay? And then go back to your graph. All right, so everybody okay? Okay, so the next thing I want to do is I'm going to put this equation in there, okay? I'm going to put this equation in there. Now, I don't like, because what I'm going to try to do is make my equation look amazing, all right? Now look, if you do a regression in here, will your calculator make it amazing? Yes, it will. That's not what I'm looking for. I'm looking for you to make it amazing, okay? So the first 5 or 6 that make it amazing and show me, I have prizes, okay? So we don't want to try to manipulate pi over 6, so we're going to turn it into a decimal. So I'm going to go on my calculator and I'm going to say pi divided by 6, and I'm going to tell you that it's 0.52355. or 524, or whatever you wanna call it. But this right here is approximately 0.523. Okay, so that's what I'm putting in for my B, 0.523. So I'm gonna go to back to y equals, and I'm gonna put this equation in. So I'm gonna go 19 times this, you need to make sure you're in radians. Oh, sorry, thanks. You need to make sure you're in radians, so if you can do that right now, punch mode and make sure you're in radians. If you're in degrees, no, it'll be bad, all right? So make sure you're in radians, and then go back to y equals. All right, 19 times the sine, there's that one parentheses, okay? And then instead of pi over 6, we're using 0.523. Open the parentheses, x minus 4.75. Close your parentheses twice, okay? And then plus 59. Graph. All right, so not too bad, all right? But do you agree that I could manipulate this curve a little bit and make it better?
Yes.
So you do it. When you get it looking amazing,
Got it.
then you tell me, and I will let you come and pick a prize up. So I'll let you have a sucker. I don't care. Here's some Minion glasses. Here's some key covers. Okay, if y'all don't know what these are, they'll go over. They won't go over the big fancy car keys, but you know, your old timey house keys and stuff. They'll go over there. Wow, I forgot about that.
I don't know what does it mean by invalid then?
That means you have the wrong number of X's and Y's. Okay, pick a prize.
Yeehaw.
Pick a prize.
Does that include a
I'm
second?
gonna.
or-
Oh no, I can't stop the video.
What exactly do we have to do? Make them like line up?
What's up,
Make
video?
it look better. Do you see how it's going off on the right hand side? What are you trying to change? What do you need to do to it? Do you agree you need to skinny it up? That's the period, right? Okay?
Can I
You
take
need
a
to
sucker?
skinny it up some?
Yes.
You need to pull it in
I
some?
said yes.
I
So
can take a
yeah.
s-
So pull it in some, all right? What are you changing if you're changing the period? Which one of those variables are you changing? The B, okay? So B, that was that number, 0.52, whatever, all right? If you're gonna, do you wanna make the period bigger or smaller? Smaller. How do you make the period? Now, you wanna make it smaller to make your curve smaller? Remember, he's with an X. What do X's do? Opposite.
So we'll make it bigger.
So there you go. Gotta be thinking, people. Gotta be thinking. What, does it say dim mismatch? Okay, so you didn't put in all your X's or Y's. Go to stat and edit.
48. And before that was
Go stat
27.
and edit. Go down. You, obviously, you have either another X.
This is about.
You don't have a 12. Okay?
I can be anyone in geometry. I can really do it.
Okay, so go in there. Are you, okay, you don't have to retype the whole thing, you can just go in there and change it. All right, so that was the number.
I do, but I don't like using it.
Right, do you wanna make it bigger or smaller?
If you can put it on.
Okay, it needs to be
If you
smaller.
can figure it out, figure it out. I don't know what invalid then means.
She said you have the room or the.
I don't know what that means.
What number do I have in the house? Where's the
I don't know. I don't know.
I don't know, that's what you gotta figure out.
About $100 calculator.
Yeah. To make it go, there you go.
Miss Davis, I got it.
You got it? Okay, put it on the phone with you.
You do it on the phone.
Yeah.
No, you gotta put the rest of your phone in there.
It's an app.
Okay, you gotta put it in there.
I'm an actual calculator and I can't do it.
Okay, and then
Figured it out.
this is twice, there's no question. Huh?
Question about it.
Okay, show me where your equation is. sure you didn't do a regression, it looks very good, go get your prize.
Yay, it's finally
Because
good.
obviously it was a cold time, it just stayed cold longer. Instead of starting to warm up in February, it stayed really cold, which it does a lot of times, so that's okay, that's a good card, go get your prize.
Yay.
Yeah, I'm going to, okay, so I'm gonna let you play with that for a second. Since we are recording, can I just go ahead and talk about a little bit about what's going on? So the period is obviously what we need to change. We need to pull this in just a little bit. Do you understand that? Okay, and which of these variables right here affects the period? Yeah, B right here, okay? So now, he's with an X, generally speaking, because he is the coefficient of X. X's do the opposite of what you think. So while your brain thinks, I need to shrink that thing, you shrink it by making the number bigger, okay? You stretch it by making the number smaller. Only because he's with an X, all right? And X's are always opposite of what you think. They're always backwards, okay? So if you made that number a little bigger, then you can see that you can affect your curve. So I'll just play, and y'all look, it's just a thing that the more you play with it, the more you learn. Okay, so I just changed the 5 to a 6. I have no earthly idea. I haven't done this. So let's see what happens.
You got it.
Well, I'd say that's not too bad. Okay? Not too bad. Might be a little bit too much. I might want to just go 600 or something like that. Do you understand what I'm saying? Sometimes you need to change your horizontal shift or something like that a little bit, and that's okay. All right? But I'm going to let you play with it. But the next thing that I'm going to ask that you do is I want to see a scatter plot and an equation for Athens. Okay? A scatter plot and an equation for Athens. I'm going to put the answer up here, and then I'm going to stop the video. I want the answer up here so the kids that are watching the video can see the video. I can see the answer, and then I'm going to stop it.
So what I'm getting is,
Very good. Go get a prize. Okay, that's good. Go get a prize. Huh?
so if we find the equation for the line, and we put in, why doesn't it match up?
Because we did the equation using the information, and it matches up pretty good. It doesn't match perfectly. We can make it better, okay? Because we're just kind of looking at it. Our graphs are not perfect, okay? So you might have to adjust it just a little bit. All right, so I'm gonna go stop the video, and then I'll turn the light back on. Okay, so I'm fixing to hand out a worksheet. I'll put that on the Teams page.